everyone. So this is the session number 18 of Advances in Post-Harvest Technology of Fruits and Vegetables, and the topic which we'll be covering today is quality measurement of fruits and vegetables. So the term quality implies a degree of excellence of a product or suitability for a particular use. Quality is a human construct comprising many properties of characteristic. Quality of produce encompasses sensory properties, that nutritive values, chemical constituents, and mechanical properties, and functional properties and defects. Chef sets out the properties often defined from either a product orientation or a consumer orientation. However, I personally have difficulty divorcing the two viewpoints and tend to think that in instrumental or sensory measurements of quality attributes are combined to provide an estimate of customer acceptability. Of course, one must always remember that there is more than one customer in the market chain. The next person or institution of the following chain can be considered a customer by previous one: grower, packer, distributor, and wholesaler. Each has judgment and each has its own set of quality or acceptability criteria. The choice of what to measure and how to measure and what values are acceptable are determined by person and institution requiring the measurement. For grades and standards of a product, the definition of a quality is formalized and institutionalized, so it has the same meaning for everyone using it. People use all the senses to evaluate quality, that is sight, smell, taste, touch, and even hearing. The consumer integrates all of those sensory inputs, appearance, aroma, flavor, hand feel, mouthfeel, and chewing sounds into a final judgment of the acceptability of the fruit and vegetable. Instrumental measurements are preferred over sensory evaluations for many research and commercial applications, because instruments reduce variations among individuals, are more precise, and can provide a common language among researchers. Some sensors are based on signals not detected by human, for example near infrared, X-rays, magnetic resonance, and electrochemical. Fruits and vegetables are notoriously variable, and the quality of individual pieces may differ greatly from the average. It is essential to determine statistically the number of pieces and the number of measurements per piece required to achieve significant representative sampling. Sampling predicts the average quality and perhaps quality distribution of a lot. Sampling does not identify the undesirable or the outstanding individual fruits or vegetables. Sorting is necessary to segregate the undesirable, acceptable, and outstanding individual pieces and to ensure the uniform quality required commercially. Other empirical methods developed to measure some particular quality attributes actually measure ripeness. Physiological processes involved in ripening and senescence occur together in a fairly predictable pattern. For example, measuring color might appear to be adequate to estimate firmness in peaches and tomatoes at harvest. However, growth conditions or post-harvest treatments may decouple the physiological processes, such as indirect measurements in no longer predict quality as expected. It is usually assumed that there is a consistent and unidirectional, although not always linear, relationship between the sensor response and the amount of the constituent or attribute. This is generally true of quantitative measurements. Electromagnetic techniques. The electromagnetic spectrum encompasses from longest to shortest wavelengths: radio wave, microwave, ultraviolet, visible light, infrared, X-ray, and gamma air radiations. Optical properties indicate the response to matter to visible light wavelength, that is 400 to 700 nanometer, sometimes given as 380 to 770 nanometer. However, now the UV is seldom used for horticultural quality measurements. X-rays is discussed separately. The other wavelengths ranging have not been successfully applied to quality measurements of horticulture commodities. Optical properties are based on reflectance, transmittance, absorbance, or scatter of light by the product. When a fruit or vegetable is exposed to light, about 4% of the incident light is reflected on the outer surface, causing specular reflectance or gloss, and the remaining 96% of the incident energy is transmitted through the surface onto the cellular structure of the product, where it is scattered by the small interfaces with the tissue or absorbed by cellular constituents. The complex physical structures of tissues creates an optically dense product that is difficult to penetrate and alters the path length traveled by it, so that the among the tissues interrogated is not known with certainty. Most light energy penetrates into a very short distance and exits near a point of entry, that is basis of color. Consumer taste, but some penetrates deeper into the tissues and is altered by differential absorbance of various wavelengths before exiting, and therefore contains useful chemometric informations. Information. Color is the basis of sorting many products into commercial grades, but concentration of pigments or other specific constituents might provide a better quality index. The incident light on a fruit or vegetable results in the specular reflectance, gloss, or diffuse reflectance from features at depth to about 5 mm body reflectance or interactance. Diffuse and transmittance or absorbance color results may vary shallow from very shallow diffuse reflectance. The CEILAB color space, that is L, indicates brightness from white to black, and B are the XY color coordinates indicating color directions. A is the red green axis, B is the yellow and blue axis, and the center is achromatic gray. The U is location around the circumference, and saturation is a distance from center. Fluorescence and delayed light emissions. Fluorescence results from excitation of a molecule by high energy light and its subsequent instantaneous relaxation when the emission of the lower light energy. Uh, Many agricultural materials fluorescence, however, nearly all horticulture applications of fluorescence involve chlorophyll. The multispectral reflectance images of tomato with viral ring spotted is shown in the figure below. That's all for this session. Thank you.